हेलो। भाई आवाज।
एम आई ऑडिबल वजाहत? अभी आपको नहीं पता चलेगा ना।
बोले बोले।
ओके, एम आई ऑडिबल?
हाँ जी। अच्छा, और दूसरा आप लोगों को
स्क्रिप्ट हो गया।
अब आर यू विजिबल?
यस।
सही आ रही है?
हेलो।
Highly audible.
या
Okay?
ओके।
Yes.
कैन यू हेयर मी नाउ?
मतलब कोई और बोल रहा होगा, आप अपना माइक्रोफोन यूज करना पड़ेगा हम दोनों में से।
क्या?
Good morning and good evening, folks.
Yeah,
Let's wait for several minutes. Then we can start. I just shared the HLD for today's meeting, so please check. Okay, let's get started. Good morning and good evening, folks. Welcome to the SONiC community meeting. Today's session comes from the Xflow. It's about the security DDoS enhancement. So before we jump into the HLD review for today's meeting, I have one thing to update. The slots for the next week is still open. So feel free to let me know if your HLD is ready for review. Okay. The second thing is like I will send out a quick summary for the 2024-05 release, maybe this week or sometime next week. So just a heads up. Okay. With that, I will hand over this to Xflow teams. So please go ahead and share your screen.
Hi, Enzo. Can you hear me?
Yeah.
This is Ali. Okay, let me share my screen.
I can see your screen. Yeah.
Okay. Hi, everyone. Good morning, good evening. This is Ali from Xflow. Today, I'll be presenting our HLD for mitigation DSCP DOS attack in SONiC. HLD has the following contents, and the design focus on implementing a rate limiting mechanism using Linux traffic control utility to protect against DSCP DOS attack in SONiC. Aim of the DSCP DOS attack mitigation is to secure the network by implementing a rate limiting mechanism. Basically, there are two main types of DSCP attacks: DSCP DOS attack and DSCP starvation attack. In a DSCP DOS attack, attacker floods the DSCP server with an overwhelming number of DSCP discover packets. This flood of discover packet consumes available resources of the DSCP server, making server unable to respond to the legitimate DSCP requests from other devices. While in the DSCP starvation attack, the attacker floods the DSCP server with a large number of DSCP request messages. Attacker accepts the DSCP server's offer messages, exhausting the pool of available IP addresses that the DSCP server can assign. As a result, legitimate devices are unable to obtain IP addresses from the DSCP server, causing network connectivity issues for those devices. Following effects occur when a DSCP DOS attack is launched on the network. DSCP server has limited resources, and DSCP discover flood consumes these resources under the DSCP attack. As a result, the DSCP server becomes overloaded and unable to serve the legitimate clients on the attack VLAN. And a server is handling a large amount of DSCP requests on the discover and the VLAN which is under attack. Legal DSCP requests experience delay and timeouts. Also, DSCP server is bombarded with a large number of DSCP discovered packets in DSCP DOS attack, and as a result, the server experiences packet loss, unable to process all incoming requests effectively. Also, when a DSCP server is flooded with an excessive volume of DSCP discover packets, the flood extends beyond the capability of the server to handle huge traffic on that VLAN. It also affects the switches, router, and other network devices, which are involved in the forwarding the DSCP traffic. The result, congestion degrades overall behavior of the network, which causes latency issues, problems, and potentially affecting the operation of other network services also. Any questions so far?
So Mohammed, so we have the some kind of a rate limiting we have already in place in hardware, right? How is this helping on top of this?
Rate limiting by
The
the
COP level rate limiting we have in hardware, correct?
yes,
For DHCP packets.
yes.
So what exactly are you doing on top of those COP limits we have for DHCP?
COP will move towards ASICs, so
Yeah.
making ASIC overloaded. So COP can mitigate, but this design will mitigate per interface to better limit fine tune.
But the
Also
number of
COP,
packets, overall packets you receive from the hardware itself is controlled, right? So
yes,
yeah, I think I'll wait for your
basically
the
TC
proposed
have
solution. Okay, all right,
more
thank you.
fine tuning as compared to corporate.
Okay, I'll let you finish everything. Thank you.
Okay, thank you. Behavior of the DSCP advanced stack. We can see that in topology diagram, PC1 and attackers are in VLAN 20, while the PC2 and the DSCP server resides in VLAN 10. The attacker basically dropped DSCP discover packets with spoofed MAC addresses and sent those packets to DSCP server and flooding the server with these spoofed draft packets. This Wireshark screenshot shows the DSCP DOS attack, showing the overwhelming packets which are targeting the DSCP server. This attack scenario shows the vulnerability of the network to DSCP DOS attack and emphasize importance of implementing security measures to mitigate such threats. In the screenshot, we can see that the PC1, which is the genuine client, is not able to get help from the DSCP server during this DOS attack. The server seems overwhelmed by a constant flow of DSCP discover package because of this DORA process cannot finish properly. Here we are facing a denial of service problem. It's clear that the network security need attention so that we can keep things running smoothly for all of users. To prevent possible DSCP DOS attack, we focus on keeping our network safe from potential DOS attacks, DSCP DOS attacks by using Linux traffic control utility. With the rate limiting, we can control how many DSCP requests come through, which help keep our network secure. Traffic control utility let us handle data efficiently by filtering packets based on different properties and making changes when necessary. We have organized traffic using queuing discipline, which manage how packets are received at the interface. By limiting the traffic coming into our interfaces, we take proactive steps to prevent DHCP DOS attack and keep our network running smoothly and safely. The proposed solution to protect against DHCP DOS attack, we implement filtering and rate limiting mechanism to ensure that the legitimate user can still access the DHCP server during DOS attack. Design allows us to apply DHCP rate limiting on a specific interface using the two parameters. One is interface and the other one is rate. By following the proposed approach, we create an ingress paying discipline in the specified interface using traffic control. Then we add a traffic control filter to target DHCP discover package on protocol 17, which is UDP protocol, and destination port 67. Finally, we apply a dropping action to any filter incoming traffic that exceeds our specified rate. This prevents the DHCP server from being overwhelmed by the excessive discover package during an attack, maintaining the network stability and security. So requirements is we have to be able to support for Linux traffic control utility for rate limiting deployment. Currently, SONiC has integrated the traffic control, and in the CLI file configuration DHCP rate limiting, we will add rate to that interface. Over. Questions so far?
Yeah, hey, this is Prince here. So one question here is this rate limiting targeted for kernel or for the ASIC? Because just to iterate on what Venkat told, we already have a rate limiting applied in kernel that's like around 300 packets per second for DHCP that is being trapped to CPU. So I believe that's the latest DHCP trap value. So so where is this traffic class rate limiting applied? Is it in the ASIC or in the kernel?
Hi, Prince. Just give me a second. Let me answer this question for you. Just give me 2 seconds. Okay, so yeah, so hi Prince, this is Asad here. Let me answer this question for you. So yes, we are implementing this rate limit in the kernel, yes, but how it differs from the already present rate limiting techniques is that with other rate limiting techniques, what happens is that you can specify one rate limit that is system-wide. And the issue that occurs from there is that when you are bombarded with illegal DHCP discover packets, what it does is it queues all the packets into one single queue and it drops every packet that exceeds the rate limit. So what happens here is that even though rate limiting is implemented, what happens is legal packets are still dropped because they're all part of one queue. And because let's say out of hundreds of discover packets, only a couple are legal. So chances, like you would say, it is most probable that all of those legal packets will be dropped, and the packets that come under the rate limit will be illegal packets. So what we were looking for in this design was a way to implement rate limiting at an interface level, so that there is a different queue for every interface, so that the packets aren't the legal packets and illegal packets are not part of one single queue. So like the way this works is, now with our design, if let's say there are 48 ports in a switch, if one single port is under attack in that switch, what will happen is that legal packets in that single port will be dropped, but we are essentially saving the other 47 ports out of those 48 ports. So that is the benefit of our design versus one single rate limit system-wide. So that is why we looked for another way to implement this, which is our design uses the Linux traffic control.
So Asad, when you say the packet will be dropped on one single port, will you install rules in the hardware to drop it?
No, this our implementation is solely in the kernel level, because Linux traffic control is a utility that exists in the kernel space. So
But the problem is
yeah.
this will not, let's assume that the packets are being forced on a single port, and it may kind of overwhelm the COP limit. Let's assume even from the single port you get 300 or 400 packets per second. So not sure if this will help because you need to drop those packets even before it arrives to the kernel. Otherwise, the COP will drop the packets, right?
Basically, the COP will actually in our testing. What happened was that the COP policy was not dropping all the packets. The COP policy was letting the packets come through. So that's why we needed an extra step in between in that.
No.
And
What I am saying is, let's assume you have this rule in the kernel, and there is one attack on one specific port, and that port is kind of sending more than the rate limit of COP, which is 300 packets per second. Now, even if you have a DHCP arriving on a different ports, because of the COP rate limits before reaching the kernel, the legitimate packets from the other port will still get dropped. It doesn't prevent, right? Because the COP is kind of restricting the packets between from the NPU to the kernel.
Right. So basically, yeah, the COP limit is around 300 packets per second, right? So when we were testing this feature ourselves, so even if the attacker stays under 300 packets per second, so like our testing, I think comprised of around 100 packets per second, and we were using ISC DHCP server for our testing. So even staying within the limits of COP, we were there was a DOS attack is still possible. So yes, our design is basically in the scope of our design is for those situations where an attacker comes and it stays under the COP limit. Because even while
So
staying
why
within the
can't
limits of COP, yes.
Okay, that means this is not a full-fledged solution, right? Why is that you are not installing a rule in the hardware? You can extend this in the having rule in the kernel to having rule in the hardware as well, right? We have Apple table support. Maybe you can block DHCP on that specific port if you determine that this is a DDoS attack happening on it.
Yes, we can for sure do that. We are open to suggestions from the community for our design. So if other than our rules that are present in the kernel, we can also add some rules in the COP level as well, as per your suggestion.
Yeah, that would be much more sort of a full-fledged solution. Rather, this doesn't prevent when the packet, and generally when there is an attacker, it's not going to be just 100 packets or something. It's going to be, when you say DDoS attack, it means there is an overwhelming amount of packets, not 100 or 200 packets. So it's better to have the solution done in the ASIC. When you determine that there is a large number of packets from a port and you hit the rate limit, you have the actual rule installed in the ASIC to prevent DHCP packets from that. That should be a better solution, in my opinion, rather than having it in the kernel.
Right. So actually, this is where I would like some suggestions from you or anyone else in this present in this call with us. So as per our testing with COP, we could not find a way to implement rate limit at an interface level. So is there any if anyone can let us know if there is
Not COP. COP is a generic policy applied on the control plane packets. But you have ACL tables. I'm not sure if you have the qualifiers today, but I can you can extend the ACL table to have a generic ACLs where you can create an ACL table and attach a polisher to it,
Okay.
and make sure that you just restrict the DHCP packet with a specific say parameters, and that should even have a much more of a foolproof solution.
All right. All right. All right. We'll definitely look into that. And we'll look into that and get back to the community on that. We'll see if we can modify our solution so that it uses the ACL to basically implement the same rate limiting at the ASIC level and not in the kernel. Are there any more questions from the community? Okay, so if there aren't any questions, why don't we just continue a little on our HRD? So we've gone past the design, the mitigation method. So we will definitely look into that and modify that. Why don't we just finish up by explaining to you guys how our CLI commands work, which will no matter what the implementation is on the back end. Let's just explain to you a little about our CLI commands, and then we can wrap up. So Ali, please go ahead.
I think you guys are muted. We are not hearing anything.
Okay, wait, let me just give us a second.
Okay. Can you hear me?
Yes, yes.
Basically, the overall SONiC architecture will remain same and no submodules will be introduced in this. So changes are made only in CLI, where rate limiting commands will be added that will imply the Linux traffic control with priority. The sequence diagram, we have to develop CLI tools to efficiently apply rate limit on interface. So we must go through a series of checks such as packet rate greater than 0 or not, and interface access, and those all checks. And when they're passed, we make a queue disk and check whether it already exists or not. If it not, we make the queue disk and add filter and rate limited that. Once the filter and rate limited is added, Linux kernel will take over and start rate limiting incoming DSCP packets on the specified interface. And the same will be for the deletion of the rate limit. First check is whether it interface exists or not, and then check which rate we want to delete exists on the interface or not. If so, then delete that rate from the interface. No SCI API changes or addition is needed for this HLD. So next section in the proposed, these are the.
So I have some question on this design.
Yeah.
Do you write something into the config DB, or you directly from the CLI to config the kernel?
No config DB changes are made in this design. We are directly implementing it on the kernel.
So then what happens if the the system gets rebooted? then how do we, how do we recover the relimiting you have applied before?
I don't. Yes, currently what we are proposing is we are not making any changing to the config DB. We are just directly writing a CLI wrapper, and the CLI wrapper will directly use the existing TC, and it will directly target to that port.
That's
But this is
definitely a
not
hack.
persistent.
It's a
Yeah.
I think it's supposed to go via the configuration supposed to go via config DB as per our architecture. You can't really like push it to kernel and then you don't worry for reboot scenarios.
Okay.
So
Yes, we can consider that as well, that we can add a new, even a new column in the interface table or a new table for the design. To
and
get it.
the user has to so basically how does user know for particular interface only you'll get the attack, like you have to the user has to configure on all potential interfaces, or like why would it to be interface, like don't you want to be like control the DOS attack on all interfaces, or
Hi. Yeah, I'll answer that question. So basically, the reason we kept yes in your case, yes, we will have to, the user will have to implement the rate limit on all interfaces. The reason we kept the option for the user to implement rate limits on an interface level is so that, because it is not necessary that a network will only have one DHCP server. So it can have multiple DHCP servers, and those DHCP servers can have different resources available. Like one DHCP server may be able to process more requests, and another DHCP server may be able to process less requests per second. So that's why we wanted to keep the option, give the option to the user, so that a network administrator will be able to see that which DHCP server is servicing which port of the switch, and according to that, they can set a different rate limit for each interface.
So I think once you come up with those, those config DB schema and the YAM model, maybe we can discuss further, how to model this, really meetings. I have one more question. Okay, so if you are going to write to the config DB, so are you going to develop some daemon that listen to those config DB changes and make those kernel changes as well?
Yeah, Gohan, it depends it depends, even if we are targeting to the DHCP relay, then there is an existing daemon that we can target to that relay. But if there is no daemon that yet, yes, we will be proposing a new daemon as well to support it for the config DB and the lower above scenarios.
So usually, right? So if you write something to the config DB, then there is a backend engine to process those changes, right? So usually that's how the SONiC design.
Yep.
Actually, you have to have a backend.
And this may need to be modified based on the design. If you are going to do with the say ASIC programming, you need to have some manager agent task also listening to this. So I would recommend take a look at this flow when you plan to change the design. If it is a kernel only, we have certain daemons which program kernel, like we have a CACL manager D, which adds the control plane ACL rules. But when you are going to change the design based on the feedback, make sure you also capture the flow in say ARC agent and other SWSs.
No, but Sudarshan, if it is just ACL, then we already have the backend, right? So basically,
that's correct, but we are not directly going to
but this is not ACL, right? So this is TC. I'm not sure.
I know, Gohan. I think the problem is here the target use case is after packet lands on the kernel, right? But as Sudarshan mentioned, we can already have a problem at the ASIC level itself if there is a real attack. So
Yeah. No.
yeah,
I get that part, but I'm thinking like, you know,
So
there's still trade-off, right? There's a trade-off between you insert those echoes in the
yeah,
insert those in the ASIC. So because the kernel definitely more flexibility. I heard that they were targeting two scenarios. I was wondering how they going to solve the second scenario they mentioned in the beginning, like the exhaustion of the address pool problem. Because even very low rate attack could still cause the address pool to be exhausted. So I was wondering how they plan to solve that problem as well.
Okay. Yeah. Firstly, Gohan, yes, as you already mentioned that we also need to focus on the trade-off. First, for the first point, agree to all of you that we can modify the design reference to how it will work with ECL, and if we are adding it, we need to target to the config DB, either a new schema or daemon, and that make it possible for the existing SONiC architecture first. The second point is there are different types of attacks. The starvation attack in the second use case or scenario, we are targeting it by creating a starvation by spoofing, like DHCP spoofing attack that can be snooping, that can be mitigate the other type of scenarios. Currently with this design, we are only targeting the DOS attacks. But yes, we are open to discussions. You guys can put your comments on the HLDPR and we can discuss offline as well to modify the design as per the requirement. Okay. Johan, do you have any other questions, or Sudarshan or Prince?
no, but what
I
are
think
you?
those are not for me. I mean, I think
So
those are
what you
the
are suggesting
main
is
comments.
either go with the kernel or with the ACL based approach. You said both have pros and cons. Like ACL may be restricted based on say the ACL capability, like ACL capability of the ASIC. Like maybe consume the resources there, which you may not want. So which approach is better to take in this scenario?
If I may add, we can also consider a design that takes both approaches. We can also consider a design that takes a combination of rate limiting in the kernel and rate limiting at the hardware level, be it through ACL. I think ACL is what we will be looking into, so that we can come up with a design that effectively picks up the pros of both methods. So
So
we can
if you
also look into
rate limited the say ASIC, not sure if you need at the for the same port at the kernel level, because ASIC is already doing the job, right? You will not get packets out of the
So
port if you are.
maybe he's saying that I'm interpreting what he said, right? So maybe what he's trying to say is that if the ASIC has the capability to do the limiting on per interface level, then he can work on a design to do that. But however, if the ASIC does not have that kind of capability, because of a hardware constraint, then he can, doing that per
That makes sense.
interface is
Yeah, that makes sense in my opinion. I'm
So,
okay with that
Guhan,
approach.
so for VS or any software only SONiC images, yeah, this makes sense. The kernel is the only place the packet landing on directly, right? So that makes sense. But when you have the ASIC, we need to leverage the hardware capability as much as possible. When
So there
something can
might
be
be,
doable in the hardware, we can
yeah,
do the same thing. Duplicate the rule on the kernel can be avoided. So we need to make sure hardware and kernel, we need to make the rule accordingly, so that we will have the complementary rules between ASIC and kernel, not the duplicate rules.
Yeah, I think we can query based on the capability. In this case, what they are planning to use. If the vendor side doesn't support the ACL capabilities or doesn't have the ACL table space, we can update the state DB, and based on it, the application, whichever they are trying to manage this feature, can take the approach of using either kernel based or ASIC based approach.
Okay.
Yeah, I
Okay. To answer Sudharshan and Venkat, yes, we can consider both approach, but right now we are focusing that the solution works for all the scenarios, even for the VS, even for the hardware, both levels. The solution works for both levels. That's why we can leverage the design as per the changes and the requirement of both scenarios and see how we can better modify it with both scenarios, because VS is just one scenario, but we need to cover the whole SONiC interfaces.
So, Rita, there is a possibility that whatever the COP limit we have, can the 300 packets per second can be full of the attacker packets, right? So if
Yeah.
you receive full of attacker packets, you are not solving anything here. Just having the TC rule at the kernel level, right?
Okay.
So you
Okay.
need to cover that scenario. So what if you get all attacker packets from the hardware? So you need to have an appropriate rule in the hardware saying that, okay, so I'm getting like overwhelmed attacker packets on this port, then you need to have a ACL rule created. I don't know, creating the ACL rule per interface may not be a ideal solution. Maybe, I don't know, you need to explore bitmap or additional qualifiers and all those things. Whatever the possibilities you could find from the ACL level, we need to leverage that as much as possible, so that with the number of attacker packets you receive in the kernel can be reduced, right? So
Yep.
you explore all the ACL options, hardware ACL options, and see, whether you can leverage all of that. I want you to like have some kind of an all the exploration for this activity, for this HLD, and then mention all those details in the HLD. And then what is possible in the kernel is known, but in the ACL side, what is possible, just clarify everything here, and then in the HLD, then we can take a look. Maybe we can have another community call review as well, if you have that all those things sorted out in the HLD.
Okay. We can also do that, Venkat, that you guys can put your comment and we can just update the HLD and
Yeah, for
yep,
sure, we'll add all the comments.
yes, just you guys can add your comments and then we'll update it and we decide even if we need a call again or just updating on the comments will cover the problem as well.
Yeah.
Okay. Yeah. Any other questions? Okay. Let's proceed with the unit testing parts. First, we just conclude this point and then we will cover all the whole idea of this is we need to mitigate the DSCP DOS attacks in SONiC. Currently, there is no way that we mitigate those attacks. We are coming up with the approach of why we not first initially target it by traffic control the existing kernel, and then we target it with the more approach toward the ASIC, as you guys already mentioned, for the ACL and for the COP behavior. But after all of your comments, we can also modify the design in as per the suggestions, and it would be great if you guys also put your comments on the HLD and we get the reviewers, so we start modifying it and come up with this more modified design as per the suggestions. Okay, so that's all from our side.
Okay, thank you, Explode teams. Any other question?
Yes, because we mimic hyperproximate behavior, but Madhav is saying do not mimic.
Okay, if you still have any other question after the meeting, feel free to leave your comments in the HLT. So the discussion can continue with the PR. With that, we will close today's meeting. Thank you, guys. See you
Thank
next
you,
week.
everyone.
Thank you.
Thank you.
Thank you, everyone.
हम ये